Have you ever found yourself needing to get quickly informed on a really complex topic, but, without feeling completely overwhelmed? Imagine trying to grasp the entire history of global manufacturing, like in a flash. From how a single bespoke car was crafted way back in 1894 to how pretty much everything we buy today is made.
Well, you've definitely come to the right place. Welcome to the deep dive.
Yeah.
Here, we basically take a whole stack of sources, articles, research, our own notes, and we pull out the most important nugget of knowledge, the key insights.
Right.
Our mission is to give you a shortcut to being genuinely well-informed. Give you those surprising facts and those aha moments that make complex stuff just click.
And today, we're taking a really fascinating journey. We're looking at the evolution of how almost everything gets made. But we're doing it through the lens of the automotive industry.
It's a great lens for it.
It really is. It's a story of constant innovation, from meticulous bespoke craftsmanship, then to the game-changing Ford assembly line, and then onto a system that's truly paradigm shifting. It's changing the world right now as we speak.
And our main source for this deep dive is, it's a landmark book called The Machine That Changed the World.
A classic.
Absolutely. It's based on this huge study, $5 million, 5 years from MIT's International Motor Vehicle Program.
Wow.
Yeah, it was this independent, really comprehensive survey. They looked at over 90 auto assembly plants across 15 countries. The researchers got incredible access, so you'll be hearing insights pulled directly from that very rigorous study.
So by the end of this deep dive, you won't just understand the fundamental differences between these big production systems. You'll also get why some companies thrive while others just kind of stagnate. And crucially, how these principles go way beyond just making cars. They apply to almost any industry you can think of.
Right. It's really universal in many ways.
Okay, so let's kick this off. Let's step back in time, way back. 1894, Paris.
Okay.
Imagine you're someone like Evelyn Henry Ellis, a wealthy English member of Parliament. And you decide you want a car. Now, this is a totally new thing for most people. Where do you even begin?
Yeah, no dealerships on every corner back then.
Exactly. No manufacturers like we know them. So Ellis went to this machine tool company, Panhard at Levassor. P&L for short.
And what's so fascinating about P&L is, they primarily made metal cutting saws, but they really embodied what we now call the classic craft production system.
Craft production. Okay.
Yeah, and it's just a world away from what we know now. This system relied, overwhelmingly on highly skilled craftspeople. They were hand-building cars, one by one, in incredibly small numbers. P&L only made a few hundred a year.
A few hundred, wow.
Yeah, and these workers, they were often independent contractors. They had this really deep, kind of holistic understanding of mechanical design, materials, everything.
So they weren't just assembling parts, they really understood the whole machine.
Exactly. And it's important to remember the design, the engineering, it often happened in these scattered individual craft shops all over Paris, not in one big central factory.
It's so fundamental to modern business thinking, economies of scale, right? The more you make, the cheaper each unit gets.
Right. That's the core idea.
But you're saying for P&L, back then, that basic economic rule it didn't apply.
That's precisely it. And it's one of those truly surprising economic facts from the source. For P&L, making, say, 200,000 identical cars wouldn't have significantly dropped the cost per car compared to making just 10.
How is that even possible?
Well, it was largely down to this problem they called dimensional creep. Parts just weren't perfectly interchangeable. You had different contractors using slightly different gauges measurement.
Oh, okay.
And then after heat treatment, parts would often warp slightly. So you needed these highly skilled fitters to literally file each part down by hand until it fit perfectly with the next part.
Wow. Filing metal parts by hand for every car.
Yeah. So by the time the last component was added, the car's actual dimensions could be significantly different from another car built supposedly to the same blueprint sitting right next to it. The whole focus was tailoring each car to exactly what the buyer wanted: performance, hand-fitted quality. Customization was key.
So custom, back then, really meant laboriously hand-fitted piece by piece.
Pretty much, yeah.
That makes Evelyn Ellis's request to Levassor, asking to move the control, the transmission, brake, engine controls, from the right side to the left, incredibly telling. For craft production, our source says it was a simple matter of just bending some rods.
Relatively speaking, yes.
But imagine asking that of a mass producer today. Making that kind of change would cost, what, millions?
Yeah.
Hundreds of millions of dollars. And years of engineering.
Oh, absolutely. The retooling, the redesign. It would be a massive undertaking. That difference alone just shows the incredible scale of change we're talking about.
So this raises the question then. If it was so customized, so focused on this hand-fitted quality, why didn't craft production last as the main way of doing things?
That's the crucial question. And from a broader perspective, the problems were, well, profound. First off, it was just prohibitively expensive. Cars were strictly luxuries for the very wealthy.
Right. Out of reach for most people.
Totally. And it also suffered from a real lack of systematic testing. This meant product quality, especially reliability and durability over time, was pretty low. Things broke down a lot.
Okay.
And maybe most critically, these small independent shops just didn't have the resources, the capital for fundamental technological innovation. So the industry hit the ceiling, what the source calls premature maturity. It couldn't really advance beyond a certain point.
Yet somehow a few craft firms did survive, right? Like Aston Martin.
Yeah, surprisingly, a few did. They carved out these tiny, ultra-luxury niches. I mean, Aston Martin made fewer than 10,000 cars in 65 years, sometimes just one car a day. They survived by being super small, super exclusive. But even they, today, need alliances with the automotive giants for specialized stuff, like emission controls, crash safety technology, things they just can't develop on their own.
So the model persisted, but it absolutely couldn't scale. Which brings us to the next big leap.
Exactly. Henry Ford.
Right. Here's where the story gets really interesting. Ford saw the limits of craft production, and he found a way to just completely flip the script. He massively reduced costs while actually increasing product quality, at least consistency, for the masses, and he called it mass production.
And his innovations really started with the Model T back in 1908.
The Tin Lizzie.
That's the one. It was designed for manufacture, absolutely, but also very much for the user. Ford famously assumed his typical buyer would be like a farmer with a pretty basic toolkit.
Right, not a skilled mechanic.
No way. The owner's manual apparently explained how to fix 140 different problems, like how to remove carbon buildup from the cylinder head using a putty knife.
A putty knife.
Okay.
That's practical.
Very. But Ford's real genius, maybe, lay in two key things. First, achieving this unprecedented interchangeability of parts.
Getting rid of that dimensional creep.
Exactly. That, combined with simplicity and making parts easy to attach, just completely eliminated the need for those skilled fitters we talked about.
Okay, that's huge. And the second thing?
The second, and maybe his most famous innovation, was the moving assembly line. He introduced it in 1914 at his Highland Park plant.
The assembly line. That feels like the real revolution.
It truly was. This single concept slashed the average worker's task cycle time. It went from 514 minutes, that's over 8.5 hours, basically a full day's work on one car section.
8.5 hours.
Down to just 1 minute.
Wow, from over 8 hours to 1 minute. That's almost unbelievable efficiency gain.
It's staggering.
So what did that do to Ford's costs? The scale. How did that fundamentally change the game?
The impact was immediate and, well, unprecedented. The more cars Ford made, the cheaper each one got. Classic economies of scale, but on a level never seen before.
Right.
By the early 1920s, he was pumping out 2 million identical Model Ts a year. And he'd slashed the cost so much that the average family could actually afford one. He democratized the automobile.
But here's something interesting from the source, right? This quality paradox.
Ah, yes. It's fascinating. Despite Ford's absolute dominance, the book points out he rarely inspected finished cars.
Really?
Yeah. No engine was even started until the car was literally ready to drive off the line. And no Model T was ever road tested by the factory.
That's wild from today's perspective.
It is. His dominance came from mastering the principles of mass production, the volume, the efficiency, the cost reduction, not from what we'd recognize now as rigorous quality control. It was a trade-off, volume over perfection.
So if we connect this to the bigger picture then, Ford's real revolution was this extreme division of labor.
Absolutely, a complete overhaul of how work was organized.
Assemblers had these incredibly narrow, repetitive tasks. The example given is just put 2 nuts on 2 bolts all day long.
Right. They didn't order their own parts. They didn't fix their tools. They didn't check quality. They probably didn't even know what the person next to them was doing, really.
And this created whole new categories of workers, right? The indirect labor.
Sure, exactly. You suddenly needed industrial engineers just to design these hyper-specific tasks, production engineers to figure out parts delivery, quality inspectors standing at the end of the line, and these rework men whose whole job was just fixing the defects found after the car was supposedly finished.
So quality control was an afterthought, something you fixed later.
Pretty much. And management's view was that workers wouldn't volunteer information or suggestions. Ideas came from foremen or those industrial engineers, not the guys on the line.
And Ford took this control thing to the extreme with vertical integration.
Oh, yeah. His obsession with controlling every single step led to what the source calls the visible hand of organizational coordination. He brought practically everything in-house at the huge Roos complex, his own steel mill, glass factory, power plant, everything.
Just mind-boggling scale. But even with all that, Ford's system, his sort of single-minded focus, had its own limitations. He didn't see them or maybe just refused to acknowledge them.
That seems to be the case, and that's exactly where Alfred Sloan and General Motors come into the picture.
Right. Sloan took over a pretty chaotic GM in the 1920s.
Yeah, it was a mess of different car companies cobbled together, and Sloan really solved the critical problems that Ford's approach couldn't or wouldn't address.
How did he do that? What were his key innovations?
Well, Sloan pioneered professional management. He set up decentralized divisions, Chevrolet, Pontiac, Oldsmobile, Buick, Cadillac, but managed them centrally by the numbers. This let a relatively small corporate HQ oversee performance without getting bogged down in the details of each division.
Smart. And he moved beyond just one model, didn't he?
That was his other masterstroke,
Right.
Product strategy. Ford famously said you could have any color Model T as long as it was black. Sloan went the other way. He offered a whole range, the famous 5-model range for every person purpose.
Right, from the affordable Chevy up to the luxury Cadillac.
Exactly. And he introduced annual model changes. Keep things fresh, give people a reason to buy a new car, even if their old one still worked fine. Planned obsolescence, basically.
Clever marketing.
Very. And these innovations, the management structure, the marketing focus, they created whole new professions we take for granted now. Financial managers, marketing specialists, they really shaped the modern corporation.
So the source suggests that around 1955, mass production hit its sort of final mature form, especially in the U.S.
Yeah, that seems to be the peak, the golden age. But then as it spread, especially to Europe, and sort of settled in, its inherent weaknesses started to show.
What kinds of weaknesses?
Well, mass production did spread to Europe by the 50s, Volkswagen, Renault, Fiat, and so on. But often, their plants were just less efficient copies of Detroit.
Interesting. They specialize differently, though, right?
They did. European companies really focused on smaller, more fuel-efficient cars, like the VW Beetle. And they introduced technical features like front-wheel drive and disc brakes earlier. American companies tended to lead more on comfort features, size, power.
But the system itself started to creak.
Yeah, by the 1970s, especially in Europe, you saw widespread worker unrest, monotony, alienation on the assembly line. It became a huge issue.
How did they deal with that?
Mostly by throwing money at it, higher wages, shorter hours, but not by fundamentally changing the work itself. So by the 1980s, mass production in the West was looking pretty stagnant, kind of stuck.
So if mass production, despite its huge impact, eventually hit this wall in the West, where did the next big breakthrough come from? How did the industry find a way forward?
That is the perfect question, because just as mass production was stagnating, this completely new approach emerged. And it was pioneered by a company that, believe it or not, was once kind of dismissed as a bunch of farmers.
Who was that?
Toyota.
Toyota, okay.
They created what we now call lean production. And as our source really emphasizes, this is where you get the true aha moments, because Toyota basically flipped so many of the core assumptions of mass production completely on their head, starting right there on the factory floor.
And I think that's where it gets really counterintuitive for a lot of people, right? Mass production was all about huge batches, never stopping the line.
Never stop the line. That was the mantra.
So how on earth did Toyota become more efficient by doing the exact opposite? Making smaller batches and even telling workers to stop the line if they saw a problem. That just sounds wrong from a mass production view.
It sounds completely wrong, but that was the genius of Taiichi Ohno, who's really seen as the founding figure of the Toyota production system.
Okay, Ohno, what were his key ideas?
Well, take die changes for the big stamping presses. In mass production, these presses stamped out millions of identical parts. Changing the massive dies, the molds could take a whole day of lost production.
Right, massive downtime.
Ohno developed techniques using simple things like rollers and clever adjustments to change those same massive dies in, get this, an astonishing 3 minutes.
3 minutes, down from a whole day.
3 minutes. And here's the really crucial part. He had the production workers themselves do the die changes, not specialized crews.
Wow. Okay, so what did that enable?
It enabled small batch production. You could switch quickly between stamping different parts. This eliminated the need for those gigantic inventories of parts sitting around, which is the origin of just-in-time or JIT production.
JIT.
But even more importantly, making smaller batches meant that if there was a mistake in the stamping process, it showed up almost instantly after only a few parts were made, not after you'd made thousands of defective ones.
So immediate quality feedback.
Exactly, leading to continuous quality improvement, Kaizen, and eliminating colossal amounts of waste from defective parts that would have just piled up in a mass production system.
And then there's the other really famous part, the andon cord.
The andon cord, yes. This is maybe the most radical idea from a mass production standpoint. Instead of finding problems way down the line, or maybe not at all, Uno empowered any worker to pull a cord and stop the entire assembly line immediately if they found a defect or even just saw a potential problem.
Stopping the whole line.
Yeah.
That seems incredibly risky. Wouldn't that kill efficiency? And how do they get workers to actually buy into that?
Yeah.
Especially with the morale problems we talked about in mass production plants.
It seems incredibly risky, but it turned out to be revolutionary. It transferred the maximum amount of responsibility and intelligence directly to the workers who are actually adding value to the car on the line.
Okay.
As for getting workers on board, Toyota fostered this deep sense of reciprocal obligation. They offered things like lifetime employment, seniority-based wages. It made workers feel like a core part of the company, a significant fixed cost in a way, but it also encouraged deep commitment and loyalty.
So job security was key.
Very key. And workers weren't just trained for one tiny repetitive task. They were trained in a wide variety of skills, often all the jobs within their work group, plus things like simple machine repair, quality checking, even handling materials ordering. They became dedicated generalists, not narrow specialists.
So multi-skilled teams.
Exactly. And proactive thinking, problem solving was actively encouraged. They used methods like the 5 whys, asking why 5 times to get to the root cause of a problem.
Right.
This is just a world away from mass production, where workers were often seen as replaceable cogs who weren't really expected to think or offer suggestions.
And the results? What did this lean system actually achieve on the ground?
The results were just staggering. The source compares the Toyota plant at Takaoka with a GM mass production plant in Framingham, Massachusetts, around the same time.
Okay.
Toyota cut defects by a factor of 3. They reduced the human effort needed by half. And they did this while drastically slashing inventories and the amount of factory space needed.
Wow. So it wasn't just saving on labor.
No. That's a key insight. It was profoundly capital saving, too. Less inventory, less space, less rework. It was just more efficient across the board.
You know, it's easy to just focus on the factory floor when you think about lean production. But the source makes it really clear that these principles extended way beyond that, didn't they?
Oh, absolutely. It permeated every aspect of the business. How cars are designed, how parts are sourced from suppliers, even how they're sold to you, the customer. It's a whole system.
Let's talk about design first. How did lean change car development? Mass production thinking was kind of faster means more expensive, better quality costs more, right?
Exactly. Those were the ingrained assumptions for 70 years. Lean design completely overturned that. The mantra became faster is cheaper and quality costs less.
How does that work?
Well, look at the comparison the book makes between GM's big GM10 program and Honda's development of the Accord around the same time.
Okay.
The GM10 program took somewhere between 7 and 9 years, faced huge problems, plans got scaled back.
Yeah.
It was a struggle. In contrast, Honda designed the Accord, a totally clean sheet design, in just 4 years, on schedule. And it went on to become the best-selling car model in North America.
4 years versus 7 to 9. That's a massive difference. What enabled Honda to do that?
A lot of it was down to their organizational structure for development, particularly the Shusa system.
Shusa.
Yeah, the large project leader, but Shusa. This person had direct control over all the necessary resources, engineering, manufacturing liaison, marketing input across different departments. They could drive the project forward rapidly without getting bogged down in endless bureaucratic sign-offs.
So one person with real authority to get it done.
Pretty much. And the productivity numbers are just stunning. Research cited from MIT and Harvard showed a typical new Japanese car design took about 1.7 million engineering hours over 46 months.
Okay.
Comparable US and European projects, 3 million hours in 60 months.
Wow. Nearly twice the effort and over a year longer.
Exactly. And this lean design capability allows companies to offer a much wider variety of products and replace them more frequently, keeping the lineup fresh. Japanese models back then averaged about a 4-year production life. Western mass producers, more like 8 to 10 years for the same basic model.
And this was supported by how they developed their engineers too, right?
Yeah, the idea of the learning organization. Japanese engineers would often spend time rotating through different functions, sales, factory operations, working with suppliers to maintain this really practical, hands-on understanding of the whole business, not just staying siloed in engineering.
Okay, so that's design. What about the supply chain? How did lean change the relationship between the car maker and the companies providing the parts?
That was another complete revolution. Mass production supply chains were often really adversarial.
Lowest bidder wins.
Exactly. Constant competitive bidding, trying to squeeze suppliers on price. This led to huge buffer inventories everywhere, and it meant defects from a supplier might not be discovered for weeks or months after thousands of bad parts had been made and shipped.
Right, because batches were huge and feedback was slow.
Precisely. Lean production completely redefined this relationship. Toyota, for example, organized its suppliers into tiers.
Tiers?
Yeah. First-tier suppliers weren't just making parts to a detailed blueprint provided by Toyota. They were deeply integrated into the product development process itself. They'd be responsible for designing entire systems like the whole brake system based on performance specifications from Toyota.
Yeah.
And they were actively encouraged to collaborate with each other.
So partnership instead of antagonism.
Absolutely. It was built on long-term relationships and shared improvement. Toyota often took a small ownership stake in key suppliers, sometimes acted like their banker, even shared personnel back and forth.
Really? They'd invest in their suppliers?
Yeah, and suppliers were strongly encouraged, expected really, to adopt Kaizen, continuous improvement within their own plants. They'd share detailed quality data using statistical process control, or SPC, with Toyota regularly.
So total transparency on quality.
Total transparency. It built incredible levels of trust and long-term commitment. It completely replaced that old model of just buying parts from whoever was cheapest this month.
Okay, design, supply chain. What about the final piece? Getting a car to the actual customer and keeping them happy. How did lean change customer relations?
Again, a stark contrast. Historically, Western distribution systems, the dealer networks, were often pretty strained and, frankly, adversarial. Dealers focused mainly on shifting inventory, haggling over price, making their margin on the sale.
Right, the classic car dealership experience for many.
Exactly. And there wasn't much effective feedback flowing from the dealer or the customer back to the factory about preferences or problems. A real disconnect.
So how did the Japanese lean producers do it differently?
They developed these dedicated sales channels. Think of the Toyota Corolla channel, for instance. Their approach was radically different. Instead of just waiting for customers to walk into a showroom, Japanese sales personnel actively visited households in their territory.
They went door to door.
Pretty much, yeah. Building detailed customer profiles, family size, driving habits, preferences, and updating them regularly over years, building a relationship.
Wow.
And because of this, and the flexible production system, the vast majority of cars sold in Japan are actually customer ordered to their specific desired spec, not just bought off the lot.
Which ties right back into the JIT and small batch production.
Perfectly. And the dealership itself is different. The heart of a Japanese dealership is usually its service area. They provide what the source calls an implicit warranty.
Implicit warranty? What's that?
It means they often fix defects, things that aren't just normal wear and tear, at no cost to the owner throughout the vehicle's normal life, way beyond the official warranty period.
Seriously, for the life of the car.
Often, yeah, within reason. It's about fostering lifetime channel loyalty. They want you to buy your next car and the one after that from them.
That's incredible service.
It is, and crucially, this whole system creates integrated feedback. Customer preferences, problems encountered in service, all that information is systematically collected and fed directly back to the product development teams.
Closing the loop.
Exactly. It makes it a truly customer-driven system, and it results in not just higher service levels, but actually lower real costs, because there's much less need for heavy discounting to move unwanted inventory.
Okay, it seems undeniable. Lean production just offers these profound advantages across the entire board design, factory, suppliers, customers.
The evidence is pretty overwhelming, yes.
So that brings us to the really big question then. If it's so much better, why isn't the entire world operating this way already? Why did those big, established mass production companies in the West struggle so much to adapt, even when they could see the success of lean systems right in front of them?
That is the million-dollar question, isn't it? And the answer, as the book lays out, is really complex. It involves a whole tangle of internal company obstacles and external market factors.
It wasn't just a matter of copying the techniques.
Not at all. I mean, think about it. Mass production swept through the U.S. and replaced craft production relatively quickly. But lean production, migrating from Japan, faced enormous resistance globally. It often triggered these nationalistic reactions when Japanese companies, the transplants, started building factories in the U.S. and Europe.
Right. Fears about jobs and competition.
Exactly. And there's a massive learning curve involved. The source highlights the experience of the NUMMI joint venture that was Toyota and GM running a plant together in California.
Yeah, I remember hearing about that.
Even after seeing Toyota's methods work miracles in their old plant with their old workforce, many GM managers initially just denied the differences. They apparently kept saying things like, they build cars just like we do.
Denial. Wow.
Yeah. The book states it took about 10 years of practice under expert guidance to effectively transfer the core principles of lean production. It's not just a set of instructions you can read in a manual, it's a whole different way of thinking, a culture.
So beyond that initial denial, what were the specific, really ingrained obstacles in Western companies and markets that made this transition so incredibly hard?
Well, the source points to several key things. First, just the deeply ingrained managerial mindset of mass production. Managers were used to hoarding information, controlling things from the top down. Lean requires openness, sharing information, empowering workers, a totally different philosophy.
Culture clash.
Big time. Second, the highly cyclical nature of the U.S. auto market, those big boom and bust cycles, that's fundamentally incompatible with lean production, which really relies on stable production levels to maintain those smooth flows, the stable workforce, the close supplier relationships. Japan's domestic market, interestingly, isn't nearly as cyclical.
That's a really interesting point about market stability. What else?
Western career paths were another issue. Workers and managers, too, often prioritize developing portable skills they can take to another company, like the old craftsman. Lean needs dedicated generalists committed to one company's system, multi-skilled team players, and the frequent layoffs common in Western boom-bust cycles completely destroy that sense of reciprocal obligation that's so crucial for worker commitment in lean.
Right, hard to feel obligated when you might be laid off next month.
Exactly. Then there were challenges with traditional labor unions in the West. The established system of rigid job classifications, job control unionism made it really difficult to implement flexible work teams where everyone does multiple tasks.
Oh.
And finally, the source points to a certain inward focus, sometimes seen in the Japanese companies themselves, especially early on. They sometimes preferred to appoint Japanese managers to run their overseas plants and favored bringing over their established Japanese suppliers. This created what the book calls investment friction and maybe slowed down the true globalization and local adaptation of the lean model.
So a whole host of interconnected challenges. Looking forward then, based on the analysis in The Machine That Changed the World, what does the future look like? Is there a path toward a truly global lean system? Or are these obstacles just too big?
The book argues the future lies in what it calls post-national companies, companies with truly global but regionally focused production systems.
Post-national, what does that mean exactly?
It means having regional production bases, say North America, Europe, Asia, that design, engineer, and manufacture products primarily for that region, with maybe just limited exports to other regions to fill specific niches or balance out production swings.
So not just building Japanese cars in America, but designing and building American-focused cars in America using lean principles.
Exactly. This strategy helps protect the company against those regional market cycles we talked about, and also against big currency fluctuations. Build where you sell.
Makes sense. What's the key to making that work, though?
According to the source, the absolute key is developing a truly global personnel system. That means hiring talented people from all regions early in their careers, giving them language skills, deliberately exposing them to different management cultures within the company, and crucially, ensuring there's equal opportunity for people from any region to rise to the very top leadership positions, breaking down that us versus them mentality.
So truly global management, not just global factories.
Precisely. And the book suggests a couple of catalysts that can drive this change. Sometimes it takes a creative crisis, like Ford nearly going bankrupt in 1982, or Mazda facing collapse in the 70s to force radical change.
A near-death experience focuses the mind.
It certainly can. Also, there's a slower, more organic spread happening from the bottom up as Western suppliers learn lean methods by working with the Japanese transplant factories and then apply those methods to their other customers.
Learning by doing, by osmosis almost.
Kind of, yeah. And governments have a role too, by promoting stable economic conditions, supporting training, and importantly, avoiding protectionist policies that actually hinder the diffusion of these more efficient lean methods.
Okay, so we've taken quite a journey here. We've dived deep into the evolution of manufacturing, starting with that costly, custom-built craft era,
P&L in Paris.
through the incredibly efficient, but also rigid, age of mass production pioneered by Ford and Sloan.
The Model T, the moving line.
And finally arriving at the flexible, high-quality, and ultimately more cost-effective lean system developed by Toyota.
Yeah, the machine that changed the world, as the title says.
And our source is pretty unequivocal in its conclusion. It states, pretty plainly, lean production is a superior way for humans to make things. It provides better products in wider variety at lower cost. It's hard to argue with that, based on the evidence presented.
It really is. But the book argues it's more than just a better way to make things.
Absolutely.
Well, if you connect it back to the bigger picture, lean production also holds the promise of more challenging and fulfilling work for employees at every level. Instead of being a cog, you're a thinking contributor.
Right, using your brain solving problems.
Exactly. And it could even potentially help dampen those disruptive business cycles in national economies because lean systems are inherently more flexible and responsive to shifts in demand.
That's a really big thought. So the final question for you listening is, what does all this mean for your work, perhaps your industry, or even just the way you approach efficiency and problem solving in your own life?
Yeah, we really encourage you to reflect on these principles. How might applying a lean mindset, thinking about value, flow, eliminating waste, continuous improvement, empowering people, how might that transform the challenges you face? Whether you're in a huge organization, a small team, or even just managing your own daily tasks.
Food for thought indeed.